Hi, so today we want to talk about derivatives of bases other than e. And up here at the top, I've kind of written what our general derivative rules are for these. So let's let a be a positive real number where a cannot equal 1, and u is a differentiable function of x. Well, here, the derivative of a to the x is just the natural log of a times a to the x. The derivative of a to the u, this is basically the same thing, is the natural log of a times a to the u times the derivative of u, and I think that kind of makes sense if you look at this one as well. The log base a of x is the derivative of that is 1 over the natural log of a times x, and log base a of u is 1 over the natural log of a times u times the derivative of u. And again, I think that kind of makes sense, and hopefully you're kind of getting an idea with the derivatives we've been dealing with and what you actually need to take the derivative of. So let's actually go through some examples here and find some actual derivatives. So for letter A here, we want to find the derivative of y is equal to 3 to the x. And we're going to look at our laws of derivatives that we have up here. So y prime is going to be equal to, well, I just have to the x here, so I'm going to have the natural log of 3 times 3 to the x. And that's it. That is our whole answer there. Not much else to do. But let's look at letter B here. We have y is equal to 5 to the 3 minus x squared power. Well, in order to do that, I want to look here. U, in this case, is equal to 3 minus x squared, and u prime is equal to negative 2x, and that'll help me once I finish writing this. So my derivative, y prime, is going to be equal to the natural log of 5 times 5 to the 3 minus x squared power times the derivative of u, which in this case we already found was negative 2x. So hopefully that kind of worked out, made sense for you. Let's go down here and do a few more. We have log base 5 of x, and we want to find the derivative of that. Well, log base 5 of x, our derivative y prime, is just going to be equal to 1 over the natural log of 5 times x. Simple enough. And I should put a multiplication symbol there. And here for part D, we have log base 3 of sine of x. Well, the u here is the sine of x, and we all know that the derivative of sine is cosine of x. So our derivative y prime is going to be equal to 1 over the natural log of 3, because we have base 3, times u, and in our here u was sine of x, times u prime. And take note that this is times u prime is not under our denominator, so times u prime in this situation is times cosine of x, right? So now we have cosine over sine, which I can rewrite as cotangent of x over the natural log of 3. And that's a good final answer for us. If you can still see that, there you go. And let's do one a little more complicated. Why not? Life is for living. So here we have, oh, I forgot to put my y equals. Well, this is y equals log base 2 of the cubed root of 2x plus 1. Well, here u is equal to 2x plus 1 to the 1/3 power. And u prime is going to equal, well, I have to do some chain rule, 1/3 times 2x plus 1 to the negative 2/3 power. And I'm just going to leave it like that. I guess if you really wanted, times 2. I can't believe I almost forgot that. If you want to rewrite it, you can have 2 over 3 times 2x plus 1 to the 2/3 power. Same thing. So let's find our derivative now. Well, y prime is going to be equal to 1 over the natural log of 2 times the cubed root of, where am I at here? Times the cubed root of 2x plus 1 times, I really didn't leave myself very good room here, but this is times 2 over 3 times 2x plus 1 to the 2/3. Hopefully you can see that these terms here, this and this, are being multiplied. And I have more room down here, so I really should have been smarter about this. But our final answer is going to be 2 over 3 times the natural log of 2 times, here I've got 2/3 power times 1/3 power, so I'm just going to end up with 2x plus 1. And that's simplified. Yes, you should be simplifying your math answers. Life is easier that way. Hopefully all of that was comprehensible and clear. If you have any questions, leave them as a comment in the video, and I look forward to seeing you in class. Goodbye.